Number 10. The Murchison meteorite. September 28, 1969. A fireball breaks apart over a small town in Australia. Chunks of rock scatter across the countryside. And because this is 1969 and NASA has labs ready to analyze moon rocks, scientists get their hands on the fragments almost immediately. What they find inside changes everything. All 5 building blocks of DNA. Over 100 amino acids, most of them rare on Earth. Sugars, precursors to RNA. Tens of thousands of different molecular compositions. More chemical diversity packed inside this one rock than humanity has ever synthesized in a lab. And here's the part that should keep you up at night. The amino acids lean left. On Earth, every living thing uses left-handed amino acids. If you make them randomly in a lab, you get 50-50, left and right. But the Murchison meteorite leans left, up to 60% for some. Same as us. This rock is 7 billion years old, older than the sun. It was carrying the recipe for life before our solar system even existed. And it's not alone. Radio telescopes have found over 100 organic molecules floating in interstellar dust clouds. The Rosetta spacecraft found organics on a comet. NASA's Stardust mission literally caught an amino acid drifting through a comet's tail. The universe doesn't just allow the chemistry of life, it mass produces it. The ingredients are everywhere, pre-assembled, falling out of the sky. The question was never whether the recipe exists out there. The question is whether it ever just sits on the shelf. Number 9. The statistical argument. Every star you see in the night sky has at least one planet. That's not a guess. That's what the data says. The Kepler Space Telescope stared at one patch of sky for years and the math came back definitive. Planets are the rule, not the exception. Now take that and run it. There are roughly 100 billion stars in the Milky Way. About 40 billion of them have an Earth-sized planet sitting in the habitable zone, the distance where liquid water can exist on the surface. 11 billion of those orbit stars like our sun. 40 billion chances, just in our galaxy, and there are 2 trillion galaxies in the observable universe. Somebody did the math on what it would take for us to be completely alone. For Earth to be the only planet that ever produced a technological civilization in the history of the universe, the odds of it happening on any given habitable planet would need to be less than 1 in 10 billion trillion. That number is so small, it's basically saying the universe would have to be rigged against life, actively hostile to it at a cosmic level. And yet, silence. No signals, no visitors, no megastructures blotting out starlight. Enrico Fermi asked the question in 1950 over lunch at Los Alamos, "Where's everybody?" 76 years later, the math still says they should be out there. The sky still says nothing back. Everything that follows on this list lives inside that gap. Number 8. ALH84001. A woman named Roberta Score is riding a snowmobile across the Allen Hills ice fields in Antarctica. It's December 27th, 1984. She spots a greenish rock sitting on the blue ice. She bags it, tags it, ships it off. 10 years pass before anyone realizes what it is. A piece of Mars. Not a metaphor. A literal chunk of the Martian crust, blasted into space by an asteroid impact 17 million years ago, drifting through the solar system and landing on Earth 13,000 years ago. The rock itself formed 4.1 billion years ago, back when Mars had rivers and lakes and an atmosphere. In 1996, a NASA team cracked it open and announced they'd found what looked like fossilized bacteria. Tiny structures 20 to 100 nanometers across, carbonate globules that formed in liquid water at around 18 degrees Celsius, and magnetite crystals, little grains of iron mineral, arranged in a pattern identical to what certain bacteria produce on Earth. The President of the United States gave a televised address about it. That actually happened. Then the pushback came. The structures were too small to be cells. The carbonates could have formed without life. Most scientists eventually landed on probably not biological. But there's one detail that still refuses to die. About a quarter of those magnetite crystals meet every criterion scientists use to identify biologically produced magnetite. No known geological process and no laboratory on Earth, including a $35 billion a year ferrite industry, has ever replicated them exactly. Shockwaves come close. Close isn't the same as there. Most researchers today say it's more likely abiotic, but more likely is doing a lot of heavy lifting in that sentence. The rock didn't prove life on Mars. What it did was force an entire field to define what proof would actually look like. The framework scientists use today to evaluate every other entry on this list exist because of this one meteorite. Number 7. The WOW signal. It's late on a Monday night in August 1977. The Big Ear radio telescope is sitting on 3 acres of Ohio farmland, scanning the sky, recording data on a line printer. Nobody's there. The telescope runs on its own. A few days later, a volunteer astronomer named Jerry Eamon sits down at his kitchen table with a stack of printouts. He spots a column of characters that shouldn't be there. 6EQUJ5, that's not a message. That's the signal's intensity over time, coded into letters and numbers. The peak U means the signal was 30 times stronger than the background noise. 30 standard deviations, that's not a blip, that's a scream. The frequency was 1420 megahertz. The hydrogen line. This is the frequency that scientists had predicted would be the most logical choice for interstellar communication, because hydrogen is the most common element in the universe. Any civilization doing radio astronomy would know it. The signal lasted exactly 72 seconds. That's exactly how long it takes for a point source in space to pass through Big Ear's field of view. It was narrowband, less than 10 kilohertz wide. Natural sources are almost always broadband. This was sharp, clean, focused. Eamon circled it and wrote one word in the margin. Wow. They looked for it again and again. For months. Then years. Other telescopes tried. In 2022, Breakthrough Listen aimed the Green Bank telescope and the Allen telescope array at the exact coordinates. Nothing. The signal has never repeated. It wasn't a satellite, wasn't a TV station. The moon was on the other side of the planet. The sun was quiet. Every terrestrial source has been ruled out. The Big Ear was torn down in 1998. There's a golf course there now. Recent work using archival data from the Arecibo Observatory found 8 similar but much weaker signals near the same frequency. The leading theory now is that a burst of radiation from something like a magnetар hit a cloud of hydrogen gas and made it glow intensely for a few seconds. A kind of natural cosmic laser that's never been confirmed in space at this frequency. So the best explanation we have for the WOW signal is a type of event that has never been observed before or since. That's the mundane option. Number 6. Oumuamua, October 19th, 2017. A telescope in Hawaii picks up an object moving through our solar system on a trajectory that doesn't belong. It's not orbiting the sun. It's passing through, coming from interstellar space and heading back out. First time that's ever been confirmed, and it's weird. Really weird. It's up to 400 meters long, but extremely narrow. A 10-to-1 length-to-width ratio. Nothing in our solar system looks like that. It's at least 10 times more reflective than a typical asteroid, shiny enough to suggest metal. It's tumbling, rotating on more than one axis, which shouldn't happen to an object that's been drifting through space for billions of years. And it's moving at roughly 196,000 miles per hour. But the strangest part is what it did on the way out. As it swung past the sun and headed back into deep space, it sped up. Not a lot, but measurably. More than the sun's gravity could account for. Comets do this. They vent gas when they get warm and the jets push them a little faster. But nobody saw any gas, no coma, no tail, no dust, nothing. A Harvard astrophysicist proposed the simplest explanation that fit all the data. A light sail, a thin, flat, reflective surface being pushed by sunlight. Artificial. The backlash was immediate and loud. Other scientists offered alternatives. A chunk of nitrogen ice from a planet like Pluto, sublimating invisibly. Trapped hydrogen gas releasing from irradiated water ice. Each one explains some of the weirdness. None of them explain all of it without introducing something that's never been observed either. And here's the thing. Since Oumuamua, 2 more interstellar objects have passed through. Borisov in 2019, Atlas in 2025. Both behave like perfectly normal comets. Tails, comas, textbook behavior, 3 visitors, 2 normal. One that broke every model we had. We still don't know what it was, and it's gone. Moving away from us at a speed we can't match, getting fainter every day. The Vera Rubin Observatory should start finding about 1 interstellar object a month once it's fully online. Maybe the next one will be normal too, or maybe it won't. Number 5. Venus phosphine. In September 2020, a team announced they'd found phosphine in the clouds of Venus, about 20 parts per billion, detected using two different telescopes. On Earth, phosphine is made by two things: industry and bacteria, specifically anaerobic bacteria, the kind that live in oxygen-free environments like swamps, penguin colonies, and the intestines of badgers. That's the full list of natural sources, factories, and guts. Venus should not have phosphine. Its atmosphere is violently oxidizing. Phosphine gets ripped apart there. For it to be present at detectable levels, something has to be actively pumping it out, constantly, faster than the atmosphere can destroy it. The scientific community did what it's supposed to do. It tried to kill the result. Reanalyses said the statistical methods were flawed. Other teams said the signal might actually be sulfur dioxide, misidentified. The original data turned out to have processing errors. The actual levels were probably 20 times lower than first reported. NASA flew an infrared observatory and found nothing. The detection was, by most accounts, dead. Then it came back. A team at Imperial College London started a long-term monitoring campaign using the James Clerk Maxwell Telescope in Hawaii. In one observing run in early 2022, they collected 140 times more data than the original detection. Phosphine showed up again. And this time, they also found ammonia deeper in the clouds, another compound that has no business surviving in Venus's atmosphere. Now here's where it gets interesting. Every observation that detected phosphine was taken as Venus's atmosphere rotated from the night side into daylight. Every observation that didn't find phosphine was taken during the opposite transition. There's a pattern. Something is happening on the night side. One important note: these newer results haven't been peer-reviewed yet. The data is real, but the conclusions are still being scrutinized. The lead scientist puts the odds at 10 to 20% that it's life, 80 to 90%. That it's chemistry, nobody understands yet. Either way, something is producing hydrogen compounds on a planet where the surface melts lead and the clouds are made of sulfuric acid. The Soviet Venere 13 lander survived 127 minutes on the surface before Venus crushed it. But 50 kilometers up in the cloud layer, the temperature and pressure are almost Earth-like. If something is alive there, it's floating in acid rain, and it's been doing it for a very long time. Number 4. Mars methane. The Curiosity rover has been driving around the floor of Gale Crater since 2012. It carries a laser spectrometer that can sniff the Martian air, and almost immediately it started detecting methane. Not much. The background level is about 0.4 parts per billion. Earth's atmosphere has 4,000 times more. But here's why even a trace matters. Ultraviolet radiation from the sun destroys methane in the Martian atmosphere within a few hundred years. For any methane to be there at all, something has to be making more. Right now, and it's seasonal, methane levels rise in the Martian summer and fall in the winter. The same pattern repeating year after year. The swing is 3 times larger than anything UV breakdown or atmospheric pressure changes can explain, and occasionally the levels spike. In 2019, Curiosity recorded 21 parts per billion, 50 times the background. Then it dropped back down within days. This is where it gets maddening. The European Space Agency has a spacecraft in orbit around Mars called the Trace Gas Orbiter. Its instruments are far more sensitive than Curiosity's. It should be swimming in methane data. It's detected almost nothing. The methane appears to only exist near the surface, only at night. By morning, convection mixes it into the broader atmosphere and dilutes it below orbital detection limits. One theory says the gas is trapped under a crust of salt in the Martian soil. Daytime heat loosens it, nighttime cold seals it back. A heavy rover driving over the crust might crack it open and release a burst. Another theory says every methane spike in the last 20 years coincides with Mars passing through the dust trail of a comet. Carbon-rich particles raining down and reacting with UV light. Or, somewhere beneath the surface of Mars, in rock that still holds ancient water, microbes are eating and exhaling. On Earth, methane-producing archaea thrive in exactly these conditions. Deep, dark, no oxygen. A NASA scientist studying the data pointed out the obvious. You'd expect life to be seasonal. Nobody can tell the difference yet. The instruments don't exist, but the methane keeps coming back. Every Martian summer. Like clockwork. Number 3. K218b. 120 light-years away, there's a planet roughly 8 times the mass of Earth orbiting a dim red star. It sits in the habitable zone. It receives about the same amount of energy from its star as we get from the sun. And in 2023, the James Webb Space Telescope pointed at it and watched starlight filter through its atmosphere. What came back was methane and carbon dioxide, both exactly what you'd expect if a water ocean existed beneath a hydrogen-rich atmosphere. But buried in the data was something else, a faint signal consistent with dimethyl sulfide, DMS. On Earth, this molecule is produced almost exclusively by phytoplankton in the ocean. It's what gives the sea that particular smell. That briny, living scent when you stand on a beach. No known geological process produces it in significant quantities. If DMS is really there, it's the fingerprint of an ocean with something alive in it. In 2025, the team published stronger evidence. The signal looked more robust with additional data. But here's the problem. A completely separate group of scientists analyzed the exact same dataset and concluded the signal isn't there at all. Same telescope, same light, same planet. Opposite conclusions. This is the wall that exoplanet science keeps hitting. The telescope doesn't see molecules, it sees light that's been slightly altered by passing through an atmosphere 120 light years away. You compare the absorption patterns to models and infer what's there. But if a molecule you've never encountered mimics the same pattern as DMS, you'd never know the difference. You can't go there. You can't take a sample. You can't sniff the air. Even if this particular detection turns out to be wrong, what it proved is permanent. We now have a telescope that can scan the atmospheres of specific alien worlds for chemicals linked to life. That capability didn't exist 5 years ago. The search just jumped from our solar system to the entire galaxy. Now, everything up to this point has been distant. Old meteorites, fading signals, objects that have already left the solar system. Exoplanets we'll never visit. From here, we're going somewhere close. Somewhere we can reach. Somewhere that has an ocean right now. Number 2. In Enceladus, there's a moon of Saturn called Enceladus. It's tiny. 504 kilometers across. You could fit the whole thing inside the state of Arizona. It's covered in ice and it should be a frozen, dead rock. It's not. In 2005, the Cassini spacecraft flew past Enceladus and saw something impossible. Geysers. Massive plumes of water vapor and ice erupting from cracks near the South Pole, shooting hundreds of kilometers into space. Saturn's entire outermost ring, the E-ring, is being fed by this tiny moon spraying its guts into orbit. Cassini wasn't built to look for life. When it launched in 1997, nobody knew Enceladus had an ocean, but the spacecraft had a cosmic dust analyzer on board, and mission controllers made a decision. Fly through the plumes. So it did, multiple times. And each pass changed the picture. The ice grains contained sodium chloride, table salt. That means the ocean is in contact with rock. Then they found organic compounds. Complex ones. Big carbon-bearing molecules. Then molecular hydrogen, which on Earth is a signature of hydrothermal vents, cracks on the ocean floor where hot water meets rock and chemistry goes wild. Life on Earth may have started at vents exactly like this, but one element was missing. Phosphorus. Every living thing on Earth needs it. DNA, RNA, cell membranes, the energy molecule ATP. Without phosphorus, you can have all the other ingredients and still get nothing. In 2023, they found the phosphorus, sodium phosphates, in the ice grains, at concentrations at least 100 times higher than in Earth's oceans, maybe 1,000 times. First detection of phosphorus in any ocean beyond Earth, which means Enceladus now has all 6: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, every chemical element life requires. The only other place in the known universe confirmed to have all 6 is here, Earth. And you don't have to land to sample it, you don't have to drill through the ice. The moon is doing the work for you. It's spraying its ocean into space, you just have to fly through and catch it. The European Space Agency has started planning a mission to do exactly that. Number 1. Cheyava Falls. July 18th, 2024. The Perseverance rover is driving through a dry riverbed on Mars called Inertve Vallis. 3.5 billion years ago, this was a river. Water rushing into a lake that filled a crater 28 miles wide. Now it's dust and rock and silence. The rover stops at a formation called Bright Angel and examines an arrowhead-shaped rock about the size of a coffee table. They name it Cheyava Falls, after a waterfall in the Grand Canyon. The first thing they notice is the spots. Small black dots, each about the width of a human hair. Scientists call them poppy seeds. They're nodules of iron and phosphorus, likely a mineral called vivianite. On Earth, vivianite forms around decomposing organic matter. Then there are the larger spots. Light centers with dark borders, they call these leopard spots. The dark material is enriched in gregite, an iron sulfide mineral. On Earth, gregite is produced by specific microbes that use chemical reactions to generate energy. Then the rover's Sherlock instrument scans for organics. It finds them. Carbon compounds embedded in the mud. This is a mudstone. Clay and silt, deposited in the presence of water. On Earth, this exact type of rock is one of the best preservers of ancient microbial life. In September 2025, after a year of analysis, NASA holds a press conference. The peer-reviewed paper is published in Nature, and the language is careful but unmistakable. We can't find another explanation. That's the acting NASA administrator. The associate administrator for science goes further. We think they are potentially made by some form of ancient life. It's a signature, a sort of leftover sign. Not life itself, the leftovers from a meal, maybe excreted by a microbe. And that's what we're seeing in this sample. Now, could non-biological processes produce these minerals? In theory, yes, but those processes require sustained high temperatures or highly acidic conditions, and the rock shows no evidence of either. The geology says this was a mild, wet, quiet environment, exactly the kind of place where microbes thrive on Earth, exactly the kind of place where they'd leave exactly these marks. This is the only finding in the history of NASA exploration to register on their confidence of life detection scale, level 1 to 2 out of 7. That might not sound like much, but consider that in decades of planetary science, across every rover, orbiter, lander, and telescope, nothing else has even made it to level 1. There's a catch. The sample is sealed in a tube. On Mars, 140 million miles away. The instruments on Perseverance can tell us what's there, but they can't tell us for certain how it formed. For that, you need to bring it home. Crack it open in a lab on Earth with instruments that don't exist on any spacecraft. NASA's Mars Sample Return Program is supposed to do this. It's also facing massive budget problems and an uncertain future. So here's where we are. The strongest candidate for evidence of alien life ever found is sitting in a sealed tube in a dry riverbed on Mars. The rover that collected it is still driving around, still operational. The rock isn't going anywhere. The evidence isn't degrading, it's just waiting. The answer to whether we're alone in the universe might already be collected, already sealed, already labeled, just sitting on another planet in a tube the size of a marker, waiting for someone to come pick it up.